This is working. Can you all see?
Yes.
Yes.
Okay. So if you're ready, yeah. So my talk today is about designing and making macro keyboards that run mostly with CircuitPython, and just like my process of making them. And yeah, so to start, here's just some background about me. I'm a high schooler, currently in 12th grade, very much like into STEM things, video games, coding, all that kind of stuff. I got some solid high school level coding knowledge, which serves me well throughout this presentation. On the right there, you can see just like, that's a picture from last year with online school, something you all should be glad you didn't have to go through. Yeah, I was taking a digital electronics class and we were like given kits of materials and we had to solder things at home. You can see all my classmates on the screen there. Yeah. So how I got into making things. There's a really good engineering program at my school. In it, I learned 3D modeling in 9th grade, which is part of the reason I'm able to do this in the first place, because you need to know how to design, you need to know how to model things if you want to make them physically. And then taking digital electronics, I learned about circuits. And then also I'm on the robotics team at Wilson, which just allows me to like actually apply all of this. So it's not just the all theoretical stuff, I can actually use it. Yeah. And then more and more inspiration, I guess. There's this YouTuber, Zach Friedman. He was the one that I guess kickstarted all of this for me. He had a video on like how to finish your weekend projects, I think is what it was called. And I watched that, and in the video, he made a macro keyboard. And I was like, oh, I could probably do that. That's cool. And then r/mechanical keyboards, I found that they have a lot of keyboards, but they're very expensive. So I was like, what if I made that but cheaper and probably worse, but it might be good, you know? That was the thought process there. So now, before we get to the keyboards though, other things I've made, thing on the left is the mess of the controller I have for this LED strip I have. It is a CircuitPython, or no, it's a Adafruit Circuit Playground Express, which is like a fun development board with the microcontroller on it, a bunch of outputs, a bunch of sensors and stuff that it was just the one microcontroller I had on hand. So I alligator clipped it to this like soldering breadboard with some buttons on it. So it's just like, it just allows you to press buttons to turn things on and off. And then that's all very interestingly plugged into that LED strip. And it looks nice if you look at that picture on the bottom right. I also made a fidget cube that uses mechanical keyboard switches because I thought it would be funny, and it turned out very well. And then finally, we're going to get to the actual things that are the topic of this presentation. But before that, basically, background on how the basic mechanism of how this works. The most electronics you really need to know to make a keyboard is you need to know how to make a microcontroller register a button input. The general idea is you have an output and you have an input, and in between that, you have the button, right? Makes sense. When you push the button, you want the input to change. However, unless most programming languages have, so in order for voltage to change, it needs to be high, it needs to be like pulled to high or low. So you need to use a resistor. That's what this rectangle here is. Most microcontrollers nowadays, they have like resistors built into their inputs, so this isn't a problem. I just made this slide because I had a problem with it when it happened. I'll just talk about that in a sec, I guess. Anyway, finally, oh wait, one more thing. This blog at the bottom, I can put that in the chat. Oh God, people are interested in it. But this is a very good overview on how like the theory behind coding a keyboard and how to design it. It's a blog I found. I think I was literally just looking up how to hand wire a keyboard, and it was good. So here, this is the first thing I made. It is sitting in front of me. I can pull it up. This is it. It works. I can push buttons on it. I can plug it into my computer. And it is the first thing. It is also, in my opinion, the worst thing, because it's the first and you'd expect it to get better. Yeah. So it is made. The microcontroller is a TC 4.0, which was way overkill for what I needed it for, which was to read inputs. And so for background, when I design things, I learned how to use, I was taught Autodesk Inventor, which is a CAD program. CAD is computer assisted design, for anyone that doesn't know. It's just 3D modeling. So this was my first time, like, I guess 3D modeling something to actually print out of a 3D printer. So I wasn't very experienced. I tried to use like one of those like, you know, those like plastic one-way teeth thingies where you like push it down and it bends enough that it can go into a hole, and then you have to pull it out by just pulling really hard. I was trying to do that, but I made it way too small and it just didn't work. So what ended up happening is it's like kind of just went in and stayed there if you didn't flip it over. I don't know, I'm rambling about design, right? But to go on, other problems that I had with this. If you see in the bottom left, I wired all of the switches directly to the microcontroller, which meant that they were like attached. You couldn't take it apart. And also those wires were much thicker than I anticipated. So they like stayed together and it was hard to move anything. Anyway, but now once I had built it, it looks nice. It looks nice just sitting there. Somehow that image on the bottom right, it doesn't even look like it's there. It looks like it's just like pasted in with Photoshop. Somehow I got the lighting very nice. But anyway, code. You might be wondering, why is this code not in Python? This is a Python talk. However, when I started, I was using a Teensy, and Teensy works with Arduino, so I wrote it in Arduino. I will get to when I switched to CircuitPython in a bit. But basically, the idea is you have the state of all the buttons and the previous state of all the buttons. If one of them changes, then if one of them changes and it changes to on, you push the button, you push the virtual button. This just means you send like the key code to the computer. And if that button releases, you release that button. Pretty straightforward. Yeah. So then we move on to the second one. The second one, I made it more purposeful instead of the first one where it was just like a big board where I could program the buttons to do whatever I wanted. The second one was very purpose-built for this rhythm game that I play called Osu. It's a rhythm game where you use like 2 buttons on your keyboard. It's that picture on the right. You use 2 buttons on your keyboard to like click circles. You aim with your mouse. Anyway, this time I used Raspberry Pi Picos, and that is what forced me into using Python, which I used for the remainder of this. Raspberry Pi Picos I got for $2 at Micro Center. I got like 5 of them for $10. It was a great deal. I also had the amazing idea of not directly attaching the switches to the microcontroller with soldering. I have a switch or like a connector in the middle. You can see it here. It's a connector. It works. You can take it apart. It works beautifully. The case itself, instead of trying to use some weird closing mechanism, I literally just designed it so that you had like a millimeter wide gap and a millimeter wide wall that like went into the gap. You can very faintly see that. Oh God, I just zoom, come on. Oh, I forgot that you can't zoom. I'll just make this really big for a sec. If you see here, there's like a gap. And basically I just have a wall that goes into that gap and it works very well. That's how that works there. Back to presentation mode. Wow. I ran into the only real problem with this one is that it goes on a desk and I'm pushing it really fast, so it would slide around and I didn't want it to. I tried fixing it by just like slapping some felt on the bottom. Kind of worked. I don't know. This one though, it's written in Python. You can see the code here. In essence, it's the same code. It checks if the state has changed. If it has, it pushes the button. If it hasn't, it releases. All of this is done with, I guess I should go over how I got the CircuitPython. It's a good idea. So basically, the whole reason I was using CircuitPython is because originally I was just going to keep using Arduino. But then when I tried to use Arduino, I found that the version of Arduino for the Raspberry Pi Pico didn't have libraries for keyboards. So then I moved to MicroPython, which also didn't have those libraries. So finally I moved to CircuitPython, which is Adafruit's branch of MicroPython, and they have a built-in HID library, which I used. It works well. The only weird part about CircuitPython is that anything running CircuitPython, the moment you plug it in, it shows up as a drive, which can kind of feel like it's, I don't know. In my opinion, it makes it feel like less official because it's always, you can look at the code. Like the code is literally just in a little drive and you just edit the code, which can be convenient, can also be weird. I don't know, up to taste. Anyway, so the code for this one, right? If the state changes and it's on, you press it. If it's not on, you release it. And then for the third button, I set up some like fancy buttons. So I can pull it out. It's in my desk. So if you push the third button, because the game itself only uses 2 buttons. So I set up the third button to do various macro things depending on what other buttons you're pressing. If you just press the third button, which is this last else statement, I don't know why I'm going from the bottom, but here we are. If you just press the last button, then it presses F2. If you are pushing one of the buttons and then you press the last button, it presses F. If you push the other one, it presses tab. If you press both of them, it does a shift tab macro, and you can do multiple presses at once with the keyboard.press. It's wonderful. And then if it's not pressed, you just release everything. It's nice. So then the only problems with this one, I guess, again, were the friction on the bottom. And since it's so thin, like you can like rock back and forth, which can be annoying. So then I made the white one. The white one is, it looks a lot better, in my opinion. I have it here. I added some rubber feet to the bottom. The rubber feet were good. I also made a very nice like space for the pico to rest, and it just looks nice. This one I tried much harder on the 3D design part. The only problem is that it is obnoxiously loud. I can give you all a sound test real quick if I move some of the switches over. Here, very loud. It's much louder than the normal keyboards, and this is a problem that I have yet to address, but I think it could be addressed by just incorporating multiple materials besides just like mostly hollow PLA plastic, which isn't very good for acoustics because hollow plastic, it's like, you know. So this one, yeah, it worked well. This one was a success. The code was pretty much, if you just cut off that second if statement, it's literally just, it presses the S and D keys when I press the 2 buttons. It's very simple. And then the third one, this is probably the best one that I've made. I made it for my dad for his birthday. This one has a spinny thing, or a rotary encoder if you're being fancy. The code I made in this one was much cleaner because I was making it for someone besides myself, so I would have felt bad if it looked terrible. And for the encoder, I copied some code from the internet, as we all tend to do. So basically, yeah, as you can see, there's 5 buttons in a row and the spinny thing on the side. It was wired again, like this one. There was a connector in the middle. Beautiful. So the encoder code, I don't really know how it works. I don't really need to know how it works. But what happens is when you turn it to the right, it increases the volume. And when you turn it to the left, it decreases the volume. Crazy. This is all, again, using the built-in libraries from Adafruit for encoders, for buttons, for all that stuff. For this one, I even made like there's a good interface. If you want to add macros, you have this key combos list. And in that you have the list of all the buttons you want to press for each button. So like if you want to, the best example is this last list, Command-Shift-M. He had that set up because that is the global mute key for Zoom. So if you press that last button, which is F5 here, then it automatically presses Command-Shift-M, and it does it all in like microsecond or whatever the hell. Heck. And so, yeah, you can change it very easily. Just add these. And yeah, so the code was cleaned up a bit also. Water. It looks through all the key combinations. Or no. Okay, so it goes through each button. It sees if the button has changed. And then if the button was not, oh my God, forgetting a lot of things. So for this one, for some reason, I reversed the logic. I honestly don't remember why, but I think it had something to do with the pull up and pull down resistors. Basically, your 2 options are you can either output high and have a pull down input, which means that it outputs at like 5 volts and the input pulls it down to 0 volts, or you can have it output at 0 volts and to have a pull up resistor on the input at 5 volts. And that all is highly dependent on what works. That's a bad way to put it. That Arduino can only do pull up, so the logic is always reversed in Arduino, but then CircuitPython can pull down. I think because of the encoder, I had to make it pull up, even though that's the annoying one. So the logic was reversed. As I said, because of reasons. That's not good coding. I did not comment that well, but you know, we live and let live. Live and let live. Okay, anyway, back to the code. I'm good at speaking. So it looks through, if the key has changed, it takes the corresponding key combination, and then if the key in that key combination is a multimedia key, it sends the multimedia key, which is like pause, play, up, down, volume, mute stuff. Otherwise, it pushes the keyboard button that it corresponds to. Those are two entirely different libraries for some reason. Guess so. Otherwise, it just releases it. And yeah, that is the gist of the things that I have made. Some challenges that I faced.
I had a question.
Yes.
Can you go back? What is the 5 millisecond sleep for? Is that because if you like hold it down or something, or?
So the point of that is that one. Oh, okay, yeah. So that basically makes it so that it doesn't run like literally as fast as possible. Just I think it's to stop it. It's both to stop it from overloading like the microcontroller itself, also to prevent it from spamming your computer with like, I'm pressing H 10,000 times per second. I would like you to know. Yeah, there's that. That's in all of the code, just like at the end of a loop, so that it doesn't spam the computer, overload the USB hub, you know. Yeah. So some challenges. I went over all of these kind of briefly. Not sure if they made sense, but if you do it with Arduino, you'll want to be researching like pull up and pull down stuff. You need it to pull. You need to have the pull up or pull down input, or else it just won't work at all. That's very important. Research that if you are interested in this. I can also talk more about it if people have questions. Faceting, I mean, just like closing the things. Don't try to do a fancy fastening method, especially if you're doing 3D printing and don't need to open it often. Because 3D printers, they make things a tiny bit bigger than what you tell them to, because it's like spitting out plastic and the plastic is like fat. But if how I designed it, you literally just give no tolerance. So like if you have a 3 millimeter wide hole, you put a 3 millimeter wide peg in it. Ideally, it just goes in perfectly, but actually you'll have to shove it in with friction and it'll stay closed, which is just an easy way to design things. If you're ever using glue, add way too much glue. It works well. I added a USB-C adapter because for some reason every microcontroller runs in micro USB, even though that's stupid, in my opinion. But anyway, yeah, I had a USB-C adapter from that, and my dad pushed it too hard and it fell out. So I just added way too much crazy glue and it stays now. And then also never directly solder things to each other. Try to have a connection in the middle. It's good. And then finally, what I would like to do next, if I continue this, when I continue this, interesting things to try. Make a custom PCB so that you don't have just wires. It is very difficult to solder wires that are not meant to be attached to things. Like wires are meant to go into a PCB printed circuit board. It's the green things. I'm assuming people know that, but I don't know. Okay, no, okay, but I would need to learn how to do that. I have no idea how that works, but it's a thing people do. You can design them online. You can send them off to China. They'll make some for you and they'll send them back. But yeah. And then the other thing I'd like to improve on is using a mix of materials so it's not as loud and obnoxious, because right now it's very loud. If you use something like foam or rubber or wood, it'll absorb the noise better. It'll be denser. It'll not be that loud. That is what I have for you today. I will take questions now.
I have a quick question. What keycaps, like what key
That's the word.
things are you
Right?
using? Yeah.
So the keycaps I have in the bottom left here, those are some keycaps I found on Amazon. They're just like standard keycaps. I don't actually use those though. Although those ones are actually also used on this one. You can buy like 10 of them for $1 or like $2. Those are just standard blank keycaps. For everything else though, my big keyboard that I can kind of hold up here, it came with a bunch of extra keys. So I've just been using those. So that's why I have 2 escape keys there. I just took them from the little bag of extra keys. And then for this one, that is from an old keyboard that I have, and I just took off the first 5 F buttons and put them on here. Keycaps, the keycaps are weird because when you buy them, usually you buy a whole set, but I didn't want to buy a whole set, so I just took them from other places. Yeah, to answer your question, there you go.
I guess, so using MicroPython, were there cases where or CircuitPython, were there cases where you were running up against the like the boundaries of what the, I guess, the framework offered, or did you feel you were kind of pretty much in the happy path of what people are using CircuitPython for?
Luckily, since most of my code was pretty straightforward, I wasn't really doing any actual calculation or any like there wasn't much actual calculation. There weren't many variables. This seemed pretty much what it was designed for. It's designed to read inputs, give outputs in a limited memory space. Most of my code wasn't more than like 200 lines. Never really ran into memory problems now.
What are like the good ways to like test out? Is there like an emulator that comes with CircuitPy or something like that? Or do you just sort of plug it in and see what the keys and circuits would do? Signal, sorry.
So yeah, I would usually, with the first one, I definitely tested it out a lot. Like maybe I alligator clipped the switch to the microcontroller and then back into the microcontroller. So you had like the microcontroller to the switch back to the input. I used that to test until I actually made sure that it all worked right. And then for the next few, I would just like, I would put in the switches, solder the two ends. So that's actually, yeah, one of the reasons why I used that connector is so I could test it better. Because if you put it all together and then test it, yeah, it's gonna probably not work, and then you'll be like, oh god, I have to take it all apart. But there's no emulator, which is what you asked. There's no emulator. I basically just made it and tested it in steps, like as I went, made sure it all worked before I put everything together, general stuff like that.
So quick question.
Mm-hmm.
Not just the key caps, but what kind of key switches were you using?
So in the first one, I bought a bunch of, I think it was like Gatoron purples and greens. I bought those on like kbdfans.com because it was $2 for 10 switches and they were cheap and they took like a month to arrive, which was kind of annoying. But I used like the green ones are clicky, the purple ones are tactile, and I split them because I wanted to. So if the greens, these are clicky, these ones are less loud. And then be right back. I must run behind me to grab the other box. For the rest of them, I bought a whole like very fancy box of switches. They are Akko rose red switches, which were surprisingly cheap as well. It was like $15 for yeah, it was like $15 for 1, 2, 3, 4, 5, 6, 7, 8, 9. $15 for like 30 switches, which is pretty good in my opinion. Yeah, so you just gotta like find them online. You can buy switches in a lot of places. Yeah. I bought these ones because I wanted linear switches. I don't know how much people here know about mechanical keyboards. I imagine it overlaps a lot, but yeah, linear ones, there's no bump while you press it, it just goes down. Tactile ones, there is a bump, and clicky ones, there is a bump, and it's loud and obnoxious. It's the gist.
Cool. Do we have any more questions for Kevin?
So, now that you've got two sort of under your belt, what are you thinking about next?
I think I would like to. I'd like to try and remake this one, maybe just with a better design, because it's just so bad in my opinion. If the case itself here, you can see it's like it just kind of slides apart. It doesn't, like, it's closed and then you just pull a tiny bit and it opens. The wires are this jumbled mess that's getting blurred. I feel like I could make this one so much better. It's also the only one where I actually used this like matrix technique, which is how you wire the keyboard so that it can have multiple rows and multiple columns. Because when you have this many, you don't actually want to wire each switch individually to the microcontroller. You want to have like each row as an output and each column as an input or something like that. And that's something that I found interesting and then didn't really get back to because all of my other ones had like 2 buttons or 3 buttons, and it wasn't that big of a problem to just wire directly. So yeah, I think I want to remake this bigger one, but better.
Have you considered any of the switches with built-in OLED displays, so you can actually change the legend on the key dynamically, but depending on context?
Actually, is that the kind of thing that they have on like Stream Decks?
Similar. I know some probably do. I just remember there was that one really old, was it the Maximus keyboard, Optimus Maximus, that was like the legend of the internet back in the day, but similar kind of concept, yeah.
Huh. No, I haven't heard of that. I'll look into that though. That sounds really interesting.
Yeah.
Thank you. Oh, I'd also like to try to like add LEDs under the keyboards. That would be cool. Oh, also one other thing. There's like a whole CNC machine at my school, and I think it would be cool to try to make one of the cases out of metal or
Nice.
wood. A CNC machine, it's a big box with like a drill that's plugged into a computer, and the computer tells the drill to move very precisely, and it can make like nice, precise things.
Yeah, if you can get aluminum, like you can get a really nice stable kind of
Mm.
base with us, like a kind of
Yeah.
a low profile.
Okay, any other questions?
I have a question. How does this project compare to what your peers do? Have they done similar things? What do you guys compare and contrast?
Most of my peers are more into coding. I have one friend who's like been doing a lot of just random stuff. He made a website for tracking DCPS COVID cases, and then realized DCPS has the exact same website already set up, which was funny. He like ripped the data off of their like announcement page. But yeah, most of my peers are either into comp sci or just aren't doing the stuff. I thought this was interesting, so I gave it a shot. Mhm.
It's interesting. Yeah.
It's also looks good on a college application. Mm. That's part of it as well.
Cool. I'm gonna stop the recording.
Okay, I'll turn